We're going to hear from Jon Morse about an organization called Boldly Go, and in a moment he's going to step in and join me to talk about a little more of what Boldly Go does. Yeah, come on over, Jon, thank you. And then we have that really great lightning round panel that will involve a lot of the major players who have been with us all 3 days here at the Humans to Mars Summit. Stick around for that. We're going to talk about lessons learned over the course of the summit and how we maintain the momentum that all of us care so much about. But Jon Morse, CEO and I think chairman of the board as well, right? For Boldly Go?
Sure. Co-founder, along with several other space scientists, and Boldly Go is a nonprofit. It grew out of our experience at NASA and at research universities, and our goal is to bring private funding into the space sciences in order to accelerate the pace of discovery. And we work with universities, industry, and with NASA through public-private partnerships.
Very worthy goal. And you come to this with great credentials. You were the director of astrophysics, right, within the Science Mission Directorate at NASA. And you were project scientist for which instrument on Hubble?
Oh, yes, I got to give a shout out to all the Hubble folks out there. 10 years ago, this week, was the last servicing mission to the Hubble Space Telescope. I've got my, oops, it's on this arm with the, I've got my lucky Cosmic Origins spectrograph shirt, which was installed 10 years ago today on there, and of course our STS-125 pin.
What a great legacy. Now, you're going to talk on stage in a couple of minutes, a few more than a couple, about a mission that I told you yesterday I've been excited about for years and years. But you do have other stuff going on, and I wonder if you could tell us a little bit about what you guys call Project Blue.
Right, and good. It's a great segue from the talk that Avi Loeb just gave, where they want to send a ChipSat out to the Alpha Centauri system. And it would be great to know whether there are planets there. We know about one around Proxima Centauri, and we would like to fly a imaging chronograph mission that's no bigger than something that could fit on your coffee table in order to investigate the habitable zones around Alpha Cen A and B, which are the two sun-like stars in Alpha Centauri. Alpha Centauri has a special proximity to the Earth that the next sun-like star is 2.5 times further away, and you need a telescope that's 2.5 times bigger in order to get the same resolution. And so Project Blue is about trying to see whether there's a blue planet, a pale blue dot, like the Earth, around one or both of the Alpha Centauri stars.
So it may be our closest interstellar neighbor, the various stars of the Centauri system, what, 4.5 light years? That's still an awfully long ways. How can you do this with such a tiny instrument?
It's called wavelength over diameter, and that sets your basic resolution. And you want to go to space to do the experiment because that's where you get the stability in order to do it at visible wavelengths that our eyes can see. And of course, you can have the optics work at their theoretical limit, just like Hubble does. So using a Hubble-like instrument, but much smaller, in a Hubble-like orbit, we can just stare at this one system, and we stare for 2 years. That's one of the keys, is that you take image and image and image after image, and what you're looking for are small variations in the succession of images in order to show a very faint planet moving in its orbit, and you use AI-based software to look for those small variations in an otherwise static, bright scene.
So it's comparable, sounds like, to the Kepler spacecraft, which has been able to discover those thousands of exoplanets because it stared and stared and stared.
That's right. That long time monitoring that's possible in space is a key aspect of this. And Kepler, of course, looked at that same group of stars and saw all those light curves and built up a tremendous number of statistics on the types of planets we may see. And so that's what's also new about trying to do direct imaging of planets around other stars, is we now know that the planetary zoo of possibilities is much broader than we thought before.
Very exciting goal, John. Best of luck with that, and also with the mission that we're going to let you go so you can go get wired up backstage, that you're going to talk to us. So we'll just tease people and say it's called SCIM, and you'll explain in moments, I guess, right?
Yes. Thank you very much.
Okay, it's called Boldly Go. I'd give you a Vulcan salute. I'll just have to leave it as live long and prosper.
Yes, thank you very much. And look, we're not subtle about where the reference comes from, but we're inspired by this story you just heard about how space exploration is for the benefit of humanity, and we want to be part of it.
Thank you, John. We'll see you on stage.